marbles to missiles, the key essentials are the same. You must have the skill, the weapon, the launch platform, and a target. With sophisticated and highly advanced missile weapon systems, unrealistic targets can no longer satisfy today's requirements. Has created the Firebee target system to provide a realistic simulation of today's threats. Because of this simulation capability, Firebees have supported missile weapons system evaluations since 1949. To understand why the Firebee is vital to these evaluations, we must examine the requirements of a weapons system evaluation program. First, you need to determine weapon system effectiveness. Secondly, you need to validate its effectiveness in the hands of the user in an operational environment. As a third and associated function, you provide realistic training to maintain air crew readiness. To accomplish these goals, you must have an effective target system. Firebee is such a system. It is a near-sonic aircraft with a maximum speed of Mach 0.96. It can be ground-launched from a zero-length launcher or air-launched from a DC-130. It has adequate flight endurance to provide multiple presentations on each flight, providing maximum utilization with minimum cost per missile firing. Firebee is recovered by a two-stage parachute system. It is then retrieved from water by helicopter or boat, or from land by helicopter or truck, and used again. This reusability, long service life, and minimum missile launch cost give Firebee true cost effectiveness. To be an effective instrument for weapon system evaluation, the target system must simulate the threat in its environment. For instance, with the Firebee, threat size is controlled on radar scopes by a traveling wave tube system that electronically varies the size of the radar image. Threat infrared signatures are simulated by flares or other heat sources. Firebee also has the capability of recreating differing threat environments. For a low-level penetration, the Firebee uses a radar altimeter low-altitude control system, RELAX. This RELAX kit automatically commands descent and maintains level flight of the Firebee at a minimum of 50 feet over the water and 100 feet over flat terrain. Firebee ECM missions may use chaff, electronic noise jamming, and deception techniques. Because attacking aircraft may be flying in formation, an automatic formation control system is now being developed for the Firebee. A manual system, developed for use only at White Sands missile range, has achieved separation distances of 300 to 600 feet. To answer the challenge of maneuvering fighter aircraft taking evasive action in dogfights over Vietnam, an increased maneuverability kit provides the Firebee with a high G-turn capability of 6 Gs in a level turn. An expansion of this capability is being developed to enable the Firebee to perform evasive maneuvers in a diving or climbing attitude. After a missile has been fired in a realistic threat environment, an index of missile accuracy must be obtained through scoring. This is essential for the data collection and analysis requirement of a weapons system evaluation program. To score ballistic and guiding armament, 2 scoring systems are carried in the Firebee, which transmit scoring information to the ground data center for analysis. Because of its weapon system compatibility, versatility, and realism, the Firebee has been used in the development phases of nearly every air-to-air and surface-to-air missile system used by the Air Force. The operational phases of evaluation and validation of these missile systems also have been supported by the Firebee. Since 1958, the Air Defense Command Weapons Center at Tyndall Air Force Base has used the Firebee for their weapons firing program, Category 3 operational suitability tests, and the William Tell Worldwide Weapons Meets. These evaluation programs are formalized and conducted under the code name Combat Pike. A Ryan contractor team presently provides all Firebee target system services at Tyndall Air Force Base. Concurrently, at Eglin Air Force Base, the Firebee is being used for tactical air command evaluation programs, such as Sparrow Shoot, Dancing Sparrow, and Dancing Falcon. Future TAC evaluation programs will also be formalized under the code name Combat Echo. One of the more vital programs is Combat Sage, under which PACAF conducts weapon system evaluations in the Southeast Asia area. The Firebee target system will support this program beginning early next year. You can see how Ryan maintains a realistic response to the requirements of Air Force weapons systems evaluation programs. Looking ahead to future needs, we are now building a new generation of Firebees, the Firebee 2, or XBQM-34E, which puts the Firebee target system in the supersonic regime. Ryan, under contract to the Navy, is building 14 prototypes for flight test and evaluation. Flight prototypes are undergoing ground testing in preparation for flight test programs. This supersonic target system will maintain the performance, operational flexibility, and threat realism of the BQM-34A. Original design specified that the Firebee 2 use existing BQM-34A systems, subsystems, components, and equipment wherever possible, that it retain the equipment carrying capability and mission performance of the existing BQM-34A, that it be air and ground launchable, and finally, that it incorporate growth potential. Firebee 2 uses a modified Continental J69 T6 engine with a new supersonic airframe. The engine accessories and compressor section were modified, and the engine was operated from 1,700 to 1,840 pounds static sea level thrust. The Firebee 2 is 5 feet longer and has a 4-foot narrower wingspan than the BQM-34A. There are no ailerons on the wing. The horizontal tail surfaces move collectively for pitch and differentially for roll control. For the supersonic mission, fuel is carried internally. However, for added endurance and more range time at subsonic speeds, 400 pounds of fuel is carried in a jettisonable external fuel tank. With the fuel tank attached, the performance of the BQM-34A is duplicated. In the clean configuration, the Firebee 2 flies at Mach 1.1 at 50 feet, Mach 1.8 at 50,000 feet, and Mach 1.5 above 60,000 feet. In anticipation of the need for more realism, the airframe and flight control system were designed to provide a maneuvering capability. It will perform 5G turns at low and medium altitudes. According to current scheduling, the Firebee 2 will begin a program of captive and powered flight testing this month. 15 powered flights will be made under ground remote control from the Naval Missile Center, Point Mugu, California. However, it was also designed to permit growth in performance. With engine uprating and airframe modification, Firebee 2 will achieve speeds in excess of Mach 2 and altitudes above 70,000 feet. In summary, from marbles to missiles, the objective is the same: to hit a target. Ryan provides target systems that closely match the realism of known threats. The Ryan Firebee target systems, in both the subsonic and supersonic regimes, are responsive to weapon system evaluation requirements and satisfy Air Force needs for the present and for the foreseeable future.